Okay, I'm going to go over simple radical form. I teach this in geometry at the beginning of chapter 9. Okay, so we've got a radical here, the square root of 25. I'm thinking what times itself equals 25, and that would be 5. And technically negative 5 times itself is also 25, but we just use the positive root typically for a problem like this, okay? On this next problem, square root of 50, well, this isn't a perfect square, so no integer times itself, now nice round number times itself is going to equal 50. Square root of 49 would be exactly 7, so it would come out a little bit more than 7, maybe 7.1 or so. So you could put that into a calculator, the square root of 50, and you get this value. So it is about 7.1, okay? And that's great, but that's not simple radical form, okay? Because that's not exact. Even this, if I put in this whole decimal for my calculator, if I wrote that all down, that's not exact either. This decimal goes on forever. That's just as much as my calculator can show. Okay, so this isn't simple radical form. So, simple radical form. The way I like to do it is think of a multiplication problem where the answer is 50. Now, I don't want to use the number 1. I don't want to use 1 times 50. But I've got a couple different options. I could do 2 times 25, or I could do 5 times 10. It doesn't matter which one you pick. I'll pick 5 times 10, okay? And then I'm going to be looking for twins. So far I have a 5 and a 10. I don't have any twins yet. So I'll see if I can break these numbers down further. I can't break down the 5 because it's a prime number. I could only do 1 times 5, and I don't want to use a 1. But I could break down the 10 into 5 times 2. So let's go ahead and do that. I had the 5 there, and now 5 times 2 for the 10, okay? And so now what I'm going to do is, now I've found a pair of twins, okay? And if you think about the radical as a jail cell, if you want to break out of jail, you need a twin, okay? So I've got my pair of twins here. So one of those twins is going to distract the guards and gets taken away and sent to solitary or whatever. But the other twin is going to get out, is going to make an escape. So one of those 5s is going to get out, and the other one kind of just disappears. And then the 2, since it doesn't have a twin, is stuck in the jail, and that's simple radical form, okay? So this is simple radical form of square root of 50. Those are equivalent, okay? And it's exact. It's not rounded at all right? So let's try square root of 200. So I'm thinking I could do 20 times 10 or 2 times 100. There's some different options. I'll start with 2 times 100. And then the 100 I could break into 10 times 10. Now, I could break the 10s up further, but you don't need to break them up further. So I found some twins. They can be grown-up twins, right? And I can take them out. So one of those will get out, one won't, one will disappear. So this is going to be 10 root 2, and that's simple radical form of square root of 200. Let's say that you did break up the 10s further. I just want to show you that, here, I'll do this up here. If you broke up, if we had this and we kept going, I just want to show you that it will end up at the same place anyway. So I could break each 10 into 2 times 5. Okay, and then, yeah, I've got 3 2s, but you make the breaks in pairs of twins. So that they got triplets, but that last triplet gets left out of the jailbreak. And then the 5s aren't next to each other, but they're still twins in the same jail, so they can also make a break. And then so a 2 will get out, a 5 will get out from this group, and then I'll have the 2 that's stuck in there. And then if you have multiple pieces on the outside of the end, multiply them together, and you can see same result, right? So no matter which way you break it up, if you do it correctly, you should end up at the same place. Okay, we can also do this with variables. So I can break down the 8. That would be 2 times 4, or 2 times 2 times 2 if you break it down all the way. Okay. X to the 3rd means x times x times x, and y to the 4th means y times y times y times y. 4 y's all multiplied together, okay? Now I'm looking for twins. I've got triplet 2s, but, only 2 of them make a break, so 1 gets left out. Same thing with the x's. For the y's, I've got quadruplets, actually, but you could think of it as 2 pairs of twins, okay? So everything that's circled, one of those is going to come out. So a 2 is coming out, an x is coming out, a y is coming out, and another y is coming out. And then the pieces still that aren't underlined are just going to stay in there. Okay, and then I just multiply everything together. So remember, y times y would be y squared. So I'm going to get 2xy squared times the square root of 2x. And that's simple radical form of this. Okay. All right. So simple radical form. There's 3 things you want to do. First is remove all of the twins, like we've been doing. Okay. Sometimes you might have fractions that need reducing, so reduce fractions. If that's the case, that hasn't happened so far in the previous examples, but it will. Okay, and another thing, if you look at these examples at the end, which I'll get to in a minute, there's no twins down there, so it looks good, but there's a radical in the denominator, and that's just a rule. You can't have a radical in the denominator for simple radical form. I'm sure there's a perfectly good reason why not. But honestly, I don't know what it is. But I do know that we have to get the radical out of there. So no radicals in the denominator for simple radical form. One nice thing about that is that, sorry, I'm trying to write and talk at the same time. But one nice thing, if you don't leave radicals in the denominator, then you don't have multiple answers that are equivalent. Everyone would get the same answer. Okay, so those are the rules. All right, so let's go back up to the top of the next column there. Okay, so I've got 2 numbers in simple radical form here. I could break down the 6, but there wouldn't be any twins. Okay, so when I'm multiplying these together, I like to just multiply the parts on the outside together. So 3 times 2 would give me 6, okay? And then for the radicals, when you multiply root 2 times root 6, you can put those under the same roof, like that, okay? Now, this would be 6 root 12 if I did the multiplication there, but it still wouldn't be in simple radical form. So, you know, a lot of times I'll get this kind of answer on a problem like this. That's still not in simple radical form because I do have some hidden twins in there. So I'm not going to actually bother, well, I already did, but usually I wouldn't actually do that multiplication. I just keep breaking down the numbers looking for twins. When I'm sure I don't have any twins, then I do the multiplication. So I've got the 2, and then the 6 would be 2 times 3, and hey, I did find some twins. So one of those gets out. Now there's already a 6 on the outside. That's okay. Now there's a 2 on the outside as well. And the 3 stuck in there. And then this is going to be 12 root 3. Okay. All right, let's try another. Now we've got some variables involved, but it's the same kind of deal. So I multiply the pieces on the outside. That gives me 6. And I can put the 5x and the 5x to the third under the same roof. Okay. Now I'm just going to rearrange the pieces in the jail a little bit. I'll put the 2 5s next to each other because that's going to be a pair of twins. You don't have to do that, but I like to do that. And then for my x's, I've got 1 x there and 3 x's there, so I've got 4 x's all together. Okay. And then looking for twins. So 5 gets out, an x is going to get out, another x is going to get out. Let's see, we've got okay, and then there's no one left in the jail, so you don't need the jail anymore. The radical's just gone, and this is going to be 30x squared. Okay. Okay, so now looking at this one, hey, there's no twins, so we're good there. We can't really reduce this fraction in this form, but we have a radical in the denominator. We have a square root in the bottom of the fraction. So since there's no twin for the 3, what I want to do is clone a twin. So I'm going to multiply by the square root of 3 down there, so I can clone a twin, okay? Now I can do that as long as I do the same thing to the numerator, because then if you think about it, I'm really just multiplying by 1. Root 3 over root 3 is 1. So I'm not changing the value of this fraction, I'm just changing its form, okay? And then I'll multiply straight across. 2 times root 3 would be 2 root 3. And on the bottom, I can put those under the same roof. And this would actually be the square root of 9, which is 3, right? So you could think about it like that, or you can do the twin escape thing. And I've got it here, okay? The last thing I want to do now that I'm dealing with fractions is see if there's any reducing that I can do. Sometimes I'll see people reduce the 3's, cancel out the 3's, but you can't do that because this 3 is in a radical and this one is not, okay? But I would want to check these parts. I would want to check, well, this part. I would want to check the pieces that aren't inside the radical. Now 2/3 is already reduced, but let's say I had 4/6, well then I'd reduce it to 2/3. But no reducing to do here, so we're good to go, okay? Same kind of deal on the next example, okay? There's no twins down there, so let's clone a twin so that we can get that radical out of the denominator, okay? And then multiplying straight across. Put those into the same root. It'd be root 49, or you can think of it as the twins. That will give you 3√7/7. Again, don't cancel the 7's, but you do want to check this part, which you can't reduce. So this is finished. That is simple radical form, okay? All right, one more example here. So again, a radical in the denominator. I can break that into 6, but there still wouldn't be any twins. So let's clone a twin again. And I've got 2√6, and you might notice the pattern. Root 7 times itself comes out to 7. Root 3 times itself comes out to 3, right? So root 6 times itself, you can put them under the same roof like that, but this is going to come out to 6, okay? And I'm done. Wait a second. Am I done? So you can't cancel the 6's, but again, I want to check this piece. So 2/6 I could reduce to 1/3, okay? And you could write the 1 up there in front of the radical, but you don't need it. I can already see there is 1√6. I don't have to write that there's one of them. It's not incorrect if you write it, but it's just not necessary. And this is simple radical form. And there you go. And I'll see you next time.